You know all that tech you use every single day? Ever stop to think what's actually running it? Well, today we're going to pull back the curtain on a language called Scala. It's kind of a big deal. It's powerful, it's elegant, and you're going to want to stick around for this. Let's get into it. All right, so let me throw a question at you. Think about some of the biggest tech platforms out there. I'm talking about Twitter, LinkedIn, even Airbnb. What's the one thing they all have in common? I mean, besides being, huge. There's a single programming language they all trust to run the whole show. Any ideas what it might be? Yup, you guessed it, it's Scala. And look, this isn't some tiny little experimental language we're talking about, no way. This is the absolute powerhouse behind some of the biggest names in the game. Think about it. This is the engine that's handling billions of tweets, right? It's managing millions of professional profiles on LinkedIn, processing all those Airbnb bookings every single day. This thing is built for the big leagues for sure. Okay, so what is the secret sauce here? What makes Scala so special? Well, it all comes down to its amazing ability to take two totally different styles of programming and just get them to work together beautifully. It's kind of like a bridge between two worlds. Let's dig in a little deeper. Here's a good way to think about it. You know the language Java, right? It's like a classic, super reliable car. It's been around for ages. It's totally trustworthy. It just works. Well, Scala, which came along in 2004, is like taking that same car and dropping a brand new, futuristic, high-performance engine inside. You still get that rock-solid reliability from the Java foundation, but now you've got this incredible, mind-blowing power and efficiency. It runs on the same roads, the same virtual machine, but it's just so much faster and sleeker. And this right here is where Scala really, truly shines. It's almost like a master chef, Someone who can take two flavors that seem like they shouldn't go together, like, say, sweet and savory, and blend them into something totally new and delicious. Well, in the world of programming, those two flavors are object-oriented and functional programming. And Scala, well, it just fuses them together perfectly. And this whole idea, this fusion of two different styles, it's not some happy accident. Nope, it's the absolute core of what Scala is all about. And the biggest clue? It's literally baked right into its name. So, Scala is actually short for Scalable Language, and that's not just a cute name, it's a promise, it's a design philosophy. It means you can start off super small, maybe just writing a tiny script to automate one little thing, and then, as your project grows, you can use that exact same language to build a massive, globe-spanning system that handles millions of users. The Lego analogy is perfect. It's like having a box of bricks that can build a little house or a giant skyscraper. So how does Scala actually do all this? Well, it boils down to these 5 key principles. First, it's concise. You get to write way less code, which is always a good thing. Second, it's got what's called type safety, which is a fancy way of saying it catches a ton of errors for you before your code even runs. Super helpful. Third, there's that perfect harmony between functional and object-oriented programming we talked about. Fourth, and this is huge, it has complete interoperability with Java. You can use any Java library out there. And fifth, it's built for concurrency, ready to tackle parallel computing right out of the box. Okay, now let's get to the fun stuff, Scala's superpowers. A lot of the magic, especially that conciseness we were just talking about, comes straight from the world of functional programming. Okay, check this out. In Scala, you've got val and var. Think of a val like something carved in stone. Once you set it, it can never, ever be changed. It's immutable. This makes your code super predictable and safe. Then you have var, which is more like writing in pencil. You can change it later if you need to. But for safety, the Scala way is to use val, that stone tablet, as much as you possibly can. And this is where you really feel that functional magic. Look at this. We have a list of numbers, 1, 2, 3, and we want to double every single one. In a lot of other languages, you'd have to write out a whole loop, maybe create a temporary variable. It gets messy. But in Scala, look at that. It's just .map _ times 2. That's it. One single, beautiful line of code. It honestly feels like a superpower.
So how is that even possible? How does it do that? Well, it's because of something called higher order functions. Now, don't let the fancy name scare you. The idea is actually super simple and powerful. It just means that in Scala, functions are treated like first-class citizens. You can pass them around as arguments to other functions, just like you would with a number or a piece of text. It's like being able to hand your friend not just a hammer, but the entire skill of hammering.
All right, another huge superpower is Scala's match expression. You might be used to if-else statements or switch cases, which are fine. They just check for simple things. But match is on a whole other level. It's like a super smart detective. It can look at complex data, take it apart, and match against intricate patterns. It's way more powerful and lets you write code that's incredibly clean and easy to read. Okay, so we've seen the awesome functional side of Scala. But let's not forget, it has a dual personality. Let's flip the coin and look at its object-oriented side. And this part is going to feel really comfortable and familiar, especially if you're coming from a language like Java or C#. And here's a really cool, fundamental idea in Scala. Everything is an object. I mean, everything. Even a simple number or a function. There are no exceptions. This makes the language incredibly consistent and elegant. You don't have to remember special rules for different types of data. It all just works the same way. And of course, Scala has all the core object-oriented concepts you'd expect. You've got classes, which are like the blueprints for your objects. You have objects themselves, which are often used for utility methods. You've got inheritance, which lets you build on top of existing code. And then there are traits, which are super powerful. They're kind of like interfaces in other languages, but you can actually put code inside them. It's like having these mix and matchable sets of behaviors you can add to any class. So we've seen how Scala pulls off this amazing trick, right? It combines the expressive power of functional programming with the solid, familiar structure of object-oriented design. But here's the real question. How does it perform under pressure? Let's talk about one of the absolute biggest challenges in modern software development, concurrency. This is where a concept called a future comes in, and it's brilliant. Imagine you order coffee at a busy cafe. They don't make you stand at the counter and wait, right? They give you a little buzzer or your name. That's a future. It's a placeholder, a promise that your coffee is coming. You can go sit down, check your phone, do other stuff. That's exactly what a future does for your code. It represents the result of some long-running task, but it doesn't block your whole program while it's waiting. So let's walk through how this works. First, your app sends off a request, maybe to a database or a web service. Instead of waiting, it immediately gets a future object back. That's your promise. Now your program isn't stuck. It can go on and do other important work. All the while that task is running in the background on a different thread. And then once the result is ready, that future gets completed with the value, or maybe an error, and your program can then use that result. It's an incredibly efficient way to handle multiple things at once. So where do you see all this power in action? Well, it's everywhere in the world of big data. Apache Spark, the biggest name in that space, is written in Scala. It's the backbone for huge back-end systems at places like Twitter and LinkedIn. It's used in financial modeling, where precision and doing things at the same time are absolutely critical. And it's a major player in machine learning and building what are called reactive systems. Basically, anywhere you have massive scale and complexity, you're going to find Scala. So really, when you boil it all down, Scala isn't just a language. It's a whole philosophy. It really does stand at this perfect intersection of pure functional ideas and massive enterprise-level engineering. It gives you the best of both worlds. So, the next time you're scrolling through Twitter or connecting with someone on LinkedIn, maybe just take a second and think about the incredible, elegant engine humming away behind the scenes. And it really makes you wonder, what else out there is powered by this amazing language?